Okay, so we got our next example. Okay, I just wanted to make sure I was recording. Again, let's see what values of x make this series converge. So we do the ratio test. This one's not alternating, so I'm not ignoring anything. And I'm going to write n plus 1 factorial as n plus 1 times n factorial. Okay, now I'm hoping maybe at this point you probably should pause the video and see, can you do ratio test on these power series on your own? I mean, this is going to be pretty routine. If you know how to do ratio test for non-power series, it's not so different doing it with power series. So don't let me do all the hard work. Okay, so now as n goes to infinity, remember x is just acting like a number, n is in the limit, n is the part that's going to infinity. So this is going to sum x over infinity, so this is going to 0. Okay, so this is different than the last case. We got an actual number instead of an expression in terms of x. So what does that mean? Well, remember, always go back to what test you're doing. You're doing ratio test, and ratio test says if our answer is less than 1, which it is, then our series converges absolutely. This series converges absolutely. Period. It's like the non-power series problems, right? It's the same thing. This series converges absolutely. This means for all values of x. So for what values? Well, we would say from negative infinity to infinity. And so there you go. There are no places where the ratio test gives an inconclusive result, because this thing will never equal 0. There are no places where the ratio test gives a divergent result, because this thing is never greater than 1. And so we're done. The series converges for all values of x. No matter what value of x you want to pick to put into that series, the result is convergent.